systematic. Okay, but the ways that everything's SRS, almost everything's SRS. Stratified, we do sometimes. Cluster, we don't do very much at all. And systematic, we don't do very much at all. The only time you'll see those two are probably in this section where they may ask you a multiple choice type question. Okay. On your test, I think I give you like a sentence and I ask you what type of sampling was this. And so you just write down what you think it is. Okay. At least that's what I've done the past however many years. So what type of sampling has done this? And I give you some type of scenario and you just tell me what it was. Was it an SRS? Was it stratified? Was it cluster? Or was it systematic? And you may use them all. You may not use them all. You may use one of them, whatever. You okay with all that? Hit me.
On the homework, there was stuff about like random digit tables and stuff.
Yep.
When you find a random digit, you have to like start again on the next line, or is it like?
Again, it's random. So typically, wherever you start, you just start going. So if you need 2 digits, wherever you decide to start, again, you can start wherever you want to. You can start to the right and go left. They don't care. The main reason for doing random digit tables so everybody gets the same answer. So if I was to do a random digit table on the test, I would say start at line 15 and go to the right. And if you're using 2 digits, that way all 29 of you guys have the same answer. That's pretty much the only reason why I would ever even tell you to use a random digit. Okay? But if you're using 2 digits, make sure you say 0, number the whatever from 0, 1 to whatever. If you're using 3 digits, make sure you number them from 0, 0, 1. That's been an AP question previously, where students get dinged because they say number them from 1 to whatever. And then you're leaving out basically 1 through 9, or if it's 3 digits, you're leaving out a bunch of numbers. Does that help you? Yep. So typically, if you go 2, they just put them in groups of 5 so you can help keep track. So if you're going by 2s, you do 2, 2, and then it'll be 1, 1. And then 2, 2, 2, 2. But again, it doesn't matter. It's random digits. Don't just pick the ones you want. Okay. Here we go. I didn't put it on. Dang it. I'm sorry. I didn't put it on Classroom. Did I? Maybe I did. Where are we in? 1? Nope, I didn't. All right. Collecting data. So 4.2 is collecting data. I guess I'll turn you on. Again, this is the whole chapter. Today it's experiments. Maybe this will work now. Why are you not working? Sorry. Okay, we'll just do it this way. Observational study. So we're going to talk about 2 things today, more than anything else, okay? Observational study and experiments. Observational study is just that. You're observing. You're observing. You're observing. Okay? Observe individuals. And remember, individuals does not have to be people. Individuals does not have to be people. Why is this button not working? Individuals does not have to be people. So you are observing and you're measuring some value of success. Oops. Measuring a variable of interest. Measuring a variable of interest. Why did I say some values of success? There we go. You're not doing anything to anybody. Okay? You're not doing anything to anybody. You're just observing. You're gathering information via a question. If I'm going to go out and measure the average of a tree, that's kind of observational study. I'm just going to go out and measure the height of a tree. I didn't do anything to that tree. If I ask you guys a question, I didn't do anything to you guys. What is your favorite subject? That is a observational study. Observational study, okay? That's opposite from an experiment. An experiment, I'm imposing some treatment. I am doing something to that individual. Okay, I'm giving that tree some fertilizer. I'm telling you to study for this long. I'm saying you can only use the book, you can't use the notes. You can use a calculator, you can't. As soon as I impose some kind of a treatment, it is now an experiment. And so several of your first couple questions are, is the following an experiment or observational study? And again, it's very, very, very simple, but you need to recognize, is it an experiment or is it an observational study? Okay? And the biggest thing about that is, in observational studies, I can't show cause and effect. You can't show cause and effect from observational studies, whereas in experiment you can, provided it's done correctly. Okay? So observational studies and experiments, two big things we got to make sure we understand about this course. Okay? It's not really a trick. Here we go. Some lady, is taking vitamin D supplement good for you? Most people say it is. Hundreds of observational studies have looked at the relationship between vitamin D concentration in a person's blood and various health outcomes. One prospective observational study, researchers found that teenage girls with higher vitamin D intakes were less likely to suffer broken bones. Other observational studies have shown that people with higher vitamin D concentration have less cardiovascular disease, better cognitive function, and less risk of diabetes than people with lower concentrations of vitamin D. So all they're doing is showing some type of a relationship between these. It doesn't prove anything. So you can't say drinking vitamin D or getting vitamin D supplements or vitamin D keeps me from getting broken bones. It helps me with cardiovascular disease, cognitive function, all that stuff, because it's just an observational study. They've shown a relationship, but they do not show cause and effect. And those are two different things. Everybody good? The observational studies involving the explanatory variable is vitamin D. That's the one that's trying to do the explaining. Come on in. That's the one that's trying to do the explaining. Okay, the response is whichever one of those we decided to get, whether it be the broken bones or diabetes or whichever one it was, right? So in statistics, we talk about the explanatory variable, the X variable, and the Y variable. You guys have heard that before in some type of mathematics, surely, right? F of X, that's your independent. That's the input. Your output is the Y. You're inputting a vitamin D, you're outputting a whatever you get from it, okay? So the response variable is the response. It's the answer. It's the outcome. That's what is the response variable? That's very possibly a question on the test. Which one is the response variable? The height of the tree. Got broken bones or not? What your favorite subject is. That is the response variable. How many siblings you have at your house. The color of your car. That is the response. Okay? Response. Pretty easy question. It's not that difficult. Response. The explanatory variable is what we're using to explain it. Okay? What we're using to explain it. color of car doesn't have an explanatory variable. The height of a tree doesn't have an explanatory variable per se. So some things don't necessarily have explanatories. But that's the one we're using to explain. Again, that's typically your x variable. If you're trying to draw a graph, that's the one that's on your x-axis. That's the one that goes left or right. The response is the y. That's typically what you're trying to plot. Okay? So explanatory and response. Again, you just got to recognize which one is which. And there'll be some of your homework questions that I ask, which one is the explanatory, or what is the explanatory variable? What is the response variable? You'll have several tonight that have an A, B, and a C part. So you have A, you click next, and it goes B, and then you click next, and you go C. So typically, one of them asks for what is explanatory, what's the response, is this an observational study, is this an experiment, that type of stuff. Everybody happy? No pencils? Boom. It has been observed that more drownings happen on days where more ice cream is sold. Therefore, if you don't want to drown, don't eat ice cream. Now see how stupid that sounds, right? They'll try to do tricks like this a lot, right? You guys that wear glasses don't eat carrots. Therefore, if you don't want to wear glasses, eat carrots. That's not true. But that's what we've heard a lot, or at least I did growing up. Okay? Studies have shown that people who exercise more have better heart health. Confounding variable. The most wrong used statement in this class. I will tell you, don't use it unless they ask for it. Don't use it unless they ask for it. If you use it, you better know for 100% sure you're using it correctly, because if you use it and it's wrong, you're going to get dinged. Students misuse this variable more than any one of them. But a confounding variable is some type of outside influence that affects both the explanatory and the response. Some type of variable that affects both the explanatory and the response. It's a confounding variable. I can't tell if the response is happening because of the explanatory or something else. I can't tell if the response is happening because of the explanatory or something else. I can't tell if there's more drownings because of ice cream or because of the heat. Y'all okay? Good? Confounding variable. It is widely misused in this class, according to AP. So just be careful about using it. Make sure if you're going to use it, you're using it correctly. My suggestion to you is don't ever use it unless if they flat out ask. Confounding variable. Let's try to explain it. Imagine you're studying whether ice cream sales cause sunburns. As the ice cream sales go up, the sunburns go up. I don't know if it's linear or not, but it's a positive correlation. As ice cream sales increase, the sunburns increase. But I don't think ice cream has anything to do with sunburns, right? The more ice cream people buy, the more sunburns there seem to be. But there's a confounding variable, temperature, right? Because as the temperature goes up, ice cream goes up. As the temperature goes up, the sunburns go up. There's a variable out there that's affecting both. Students often say it affects this, but you have to relate it to both. And that's where they mess up a lot, okay? When you talk about a confounding variable, make sure it links both the explanatory and the response. Make sure it links both of them. And that's where students mess up. They'll link it to the response, but they'll forget to link it to the explanatory. It's got to link to both. Any questions about a confounding variable? Anybody still writing? confounding variable. Studies have shown that people who exercise more have better heart. Diet has a potential to be confounding. I can't tell that those who exercise more or also have a better diet. Those that have better heart also, is it because of the diet or is it because of exercising more? Okay, so that diet has to link to both of them. Without controlling diet, we can't be sure if the exercise alone improves heart health. Diet confounds it. If you're asked to identify possible confounding variables, so I'll try to give these out throughout the entire year. Not only is this an AP exam tip, this is your test tip, right? If you're asked to identify possible confounding variables of a given setting, you are expected to explain how that variable you chose is associated with the explanatory and the response. And I said that just a second ago. Again, students misuse that a lot. They'll associate with the explanatory, the response. They'll forget to link it to the explanatory. Clicky, click, click. Clicky, click, click. To determine if taking vitamin D causes a reduction in diabetes risk, researchers in Norway performed an experiment. So now we're going to do an experiment. The researchers randomly assigned 500 people with pre-diabetes to either take a high dose of vitamin D or a placebo. And a placebo is a pill that looks exactly the same, it just doesn't contain anything. After 5 years, 40% of the people in each group were diagnosed with diabetes. Okay. Factor. That's the variable that's manipulated or controlled. In this particular experiment, the factor is the vitamin D pill. I guess there were two factors, the vitamin D pill or the placebo. But the factor is the thing that's manipulated or controlled in the experiment. Use the book, use your notes. The factor is the book or the notes. That is the variable that's being manipulated. That is the variable that's being manipulated. What are the factors? What is the factor? There may only be one factor, or what are the factors? So the factor. Okay, we gotta know all these definitions. Factor. It's the variable that's manipulated or controlled. We're wanting to examine the effect of different fertilizers on plant growth. So we're going to give them fertilizer A, fertilizer B, and fertilizer C. The factor is the fertilizer. The factor is the fertilizer. There's not three factors. The factor is a fertilizer. There's three levels of it. So that's the specific conditions. So when I said the pill, the vitamin D, or the placebo, that's really two levels. The factor is the vitamin D pill or the pill. How about that? The factor is the pill. There are two levels, the real pill and the fake pill. Levels is typically a number, if that helps you. Levels is typically a number. Specific values or conditions under which the factor is tested. Each factor can have multiple levels. Each factor can have multiple levels. I'll clean all this up in one slide, I hope. Last 2 years it's helped. So we got factors and we got levels. All of this happens with experiments. None of this happens with observational studies. None of this stuff happens with observational studies. You're not doing anything to them. These are all with experiments. Factors, levels. Factors, levels. Factors is what we're doing. Levels are basically how many. If the factor is a type of fertilizer, it could be no fertilizer, organic fertilizer, and synthetic fertilizer. So fertilizer is a factor. There are three levels. Factor is the fertilizer. There are three levels of it. And then treatments. And sometimes the treatments and the levels are the same. but it's the combination of factors and levels. It's the combination of factors and levels. Combination of factors and levels. I forgot what we said, organic or whatever, but fertilizer A, B, and C. Fertilizer A, B, and C. So the factor was the fertilizer. These are the levels. And that's also the treatments. There's 3 treatments. There won't always be, the levels and treatments won't always be the same. I got an example of that in just a second. That again, I think clears up everything. So factors, levels, and treatments. And the treatments are basically, this tree's getting fertilizer A, this one's getting fertilizer B, and this one's fertilizer C. So there's 3 treatments, which happens to be 3 levels. Pencils? Pencils? Too fast, too slow? Click. Okay, we just did that. In many instances, the level and treatments are the same. Experimental unit, that's what I'm doing it on. Who I'm doing it to, what I'm doing it on, whether it be the students, whether it be the trees, whether it be the cars, whether it be whatever I'm doing it on. The object which the treatment is assigned to, whether it be the bunny rabbits, whether it be the dogs, whether it be the students, whether it be whatever I'm doing it on. In this particular case, the trees or the grass, or I forgot what I was doing that one too. The experimental units. Units is a single, right? So that's who I'm doing it to or what I'm doing it on. So it's very possible that they give you some type of scenario and they ask you each one of those questions. What is the factor? What are the levels? What are the experimental units? And how many treatments are there? Or what are the treatments? A lot of words. Whew. Remember, you signed up for a math class. Told you. Happy, happy, joy, joy, joy. Good? Anything? Okay. This is my example that I've come up with that tries to sum this all up, that seems to help. Okay, I'm going to bake some brownies. Bake some brownies and test how they cook in different ovens. So let's just stop right there. I'm going to bake some brownies and how they cook in different ovens. So what are my experimental units? The brownies, right? The brownies. That's what I'm doing it on. That's what I'm doing it to. The brownies are experimental units, okay? What are the factors? The oven. The oven. How many levels are there? Well, I didn't tell you. So I got a gas oven and an electric oven. Okay, so I got 2 ovens, 2 different types of ovens. So there's 2 levels. Okay, so how many experimental units are there? Or I'm sorry, how many treatments are there? There's 2. Okay, there's 2. Now, we're going to compare gas oven and electric oven. But not only do I want to test ovens, I also want to use different types of pans, because the pan may also have an effect on that. And so I'm trying to control all this. So I have a gas oven and electric oven, and I have a glass pan and a metal pan and a silicone pan, and I don't know if that's even true, but I made it up. Y'all okay? So now my experimental units are still the brownies. My factors are, now I have 2 factors. I have the oven and I have the pan. And this one has 2 levels, and this one has 3 levels. So you don't say there's 5 levels. This one has 2 and this one has 3. They're separate. Okay? But now that means that I have 6 treatment groups. I have 6 treatment groups because we have this oven, and this bad boy goes out 3 ways, and this bad boy goes out 3 ways. And so that gives me 3 down here and 3 down here, which gives me 6 treatments. Click. That's all this is. What are the experimental units? The brownies. The brownies, the cake mix, whatever you want to call it, right? There are several answers here, just don't lie. If you want to say the brownie mix, if you want to say the mixture of brownies, if you want to, whatever you're going to do, right? That's what we're using as my experiment. Okay? Those are my experimental units. The brownie mix, the factors. Okay, so the oven is one of them, and then the pan is one of them, and this one has 2 levels and this one has 3 levels. Again, don't say there's 5 levels. There's not 5 levels. They're separated. This one has 2 and this one has 3. This one may only have 1. If it has 1, then really it's not a treatment group. I mean, that's not a level. And then so there's the treatments, and it's the factors of all those. It's the factor of all those. So it's the gas with the glass in the middle and the silicone, and it's the electric with the glass in the middle and the silicone. Questions about all that? You've got to be familiar with all that terminology. You've got to be familiar with that terminology. Factors, experimental units, levels, and then what? Treatments. Okay? Experimental units, factors, treatments, and levels. Clear as mud? Click. Oh, what's the response variable? How they came out, how they taste. Yeah, what they look like. I don't know. All those type of things, right? What I put. The quality. How about that? Ooh, that's a good word. Ooh, must have been smart on that day. The quality of the brownie. How they taste. How they look. Are they soft and gooey or hard and crunchy? I don't even like brownies. I need to change that to Cheez-Its. Placebo. Placebo. It's a treatment that has no effect. Treatment that has no active ingredient. Okay. You can only give placebos to humans. A tree doesn't care if it has an active ingredient or not. A bunny rabbit doesn't care if it's an active ingredient or not. I'm going to give this dog this energy pill, and I'm going to give this dog a placebo. So it doesn't know. It doesn't know. So the placebo can only be given to humans. But it's one that acts like it is. Okay? And the reason why we have to do that is because of the placebo effect. And the placebo effect is because you're taking it, you feel like you should be doing better. Right? My old grandma, way back in the day, 86-year-old, was not feeling all that great, and she decided she needed some medicine. She was just getting old, bless her heart. So we took her to the doctor. The doctor says she's healthy as a horse, considering she's 86 years old. She said, well, I've been taking this medicine and I feel a whole lot better. And the doctor says, okay, here you go. Gave her a vitamin. Didn't do anything. Just made her feel better because she was taking her medicine. I messed up and took 2. Am I going to overdose? No, you'll be okay, Grandma. It's okay. Take 3 or 4. Be all right. Placebo effect. Again, only humans can get this. Uh-oh. This is supposed to go to something. I don't know what it goes to. Oh, I remember now.
Hi, I'm Nick Watt from ABC News, and I'm here with my friends Sashir and Scott. And tonight, we're going to venture out into the real world to unlock the secrets of human behavior. So, psychological experiment.
Of people who happen to pass us by.
Exactly. Hi, my name's Nick, and I work for the Wick Power Energy Drink Corporation. Would you like to look like this?
I'm strong.
My trucks are tight. Well, what's inside this bottle can make you feel strong. day, we set up a booth on the boardwalk of the beautiful Jersey Shore one sweltering hot day. We told vacationers we're shooting an infomercial for a fabulous new energy drink. We had t-shirts and posters. We even had our very own Whip Power energy drink banner plate. Oh, and one tiny little secret. Whip is nothing more than club soda. You see, we're demonstrating the power of the placebo effect today. So all we did was tear the labels off of club soda bottles and stick on our own. Whip, would you fall for that? Would you actually feel stronger after a few gulps? You will be amazed.
What we got going on right here is the Whipped Energy Challenge. We're promoting a new drink, and it shows immediate results. Who wants to step up and take it? It's totally free.
Who's done?
First up, we invite our passers-by to test their strength. Classic carnival eye striker. Swing the mallet, try to ring the bell. 7, Maxine. That's respectable. It's not stellar. So Shearer's going to give you some whips right now, and we will increase your performance. Whip, 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 whip. So he chugs the whip, and I tell him some highly convincing nonsense about what's in it. It was discovered by Philip Monroe, who won the Tour de France in 1998. Then we get him to shake his thing, get the whip pumping through those veins.
Punch all those distractions out of your way. Don't punch me. Punch everything else up.
Then the line striker see just how much stronger whip has made him. Will he get a better score? Stand back, boys. Keith is on fire. Yeah!
I'll see a couple of issues with this though, right? I mean, at first they have them do it just blind, and then they tell them all about it, and then they kind of pump them up a little bit. Plus, you've already done it once, you kind of get a better idea. I think you probably would have hit it better the second time, no matter if you did anything or not. But anyway, they all do this. It goes through an 8-minute type deal. I don't want to waste your time on it. I figured out that it's not that great of a video, but sure enough, everybody does seem to do better after they drink this stuff, because mentally, and that proves to you guys how strong the mind is. The mind can overcome a lot of things. It's really impressive. So anyway, they go through and tell them all that stuff, and at the end of it, they tell them that it was just water, and then they feel like an idiot.
With Pondweed.
He makes up all this stuff what's in.
And it works on Molly too. Yeah, 5! Got a 5! What did the whip do to you? Bubbles really? Yeah. Coming off and jittery. It even works on kids. You scored 3.5, then you went up to 6 after a few sips of whip. Where do you feel it? In your arms, in your core, in your head? Where is it? You feel it in your head. He's absolutely right. It is all in your head. But when Jeff realized it was all in his head. Yeah! Jeff! You're the man! You're the man! I told you were good for this. Where do you feel it? Where do you feel the whip? Where is it in you? Everywhere. It's everywhere. Nearly every single person who took the whip challenge beat their original score. The placebo effect is that good. Was pretty good. It did. Yeah. Where's the energy?
I felt like I had more oomph. I feel
Okay.
my body just like more energy. I felt like an extra boost in my body.
Bubbles really. Yeah. Kind of all pumped up and jittery. Remember, just drink club soda. So how did our pumped up winners take the truth? I think I've got a secret to share with you. That what you just drank there. Club soda.
No, it wasn't. No, it wasn't.
Really? Really? Club soda. Because you know what? Your power is in there. You're strong. It's all in the mind. It's called the placebo effect. You think it's working on you, so it does work. It's in there. It's
Y'all okay with all that stuff? Good. Beautiful, 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 beautiful. Again, you can't give a placebo effect to dogs. They don't care. I say that because people have written that several times. All right. Research from Rutgers University used the 5-second rule. Y'all heard about the 5-second rule. As long as you pick it up quick enough within 5 seconds, it's still good. It's still safe to eat. They've used 4 different types of food. Watermelon bread, bread with butter, and gummy candy, whatever. They dropped it on the food in 4 different surfaces: stainless steel, ceramic tile, wood, and carpet. And then they waited 4 different lengths of times: 1 second, 5 seconds, 30 seconds, and 300 seconds. Finally, they used bacteria prepared in 2 different ways: triptych, soil broth, and peppertone, whatever. Once the bacteria were ready, the researchers spread them out on different surfaces and started dropping food. List the factors in this experiment and the number of levels for each factor. Y'all okay with all this stuff? So what was one of them? The type of food. And number 4, surface. And there were 1, 2, 4. Time. And there was 1, 2, 3, 4. And then bacteria, which there were 2. And so how many types of food? 4. Surface. 4, 4, 2. And so how many, what was it? Treatments, whatever, all that times each other. 4 times 4 times 4 times 2. I can't imagine you ever seeing something that high in this class. But y'all okay? Good? Questions? Okay. We beat all that up. All right, comparison. When we're doing experiments, guys, we need a comparison some way, some form, some fashion. We got to have something to compare it to. And so that's what the control group is, okay? That gives us our baseline. That gives us what we're comparing it to, okay? If I'm trying to test that fertilizer, okay, my baseline or my control group might be nothing. It might be nothing, right? But we got to have some kind of a control. It might be nothing. It might be what we previously did. If we previously used fertilizer A, then that would be the control. Again, we just got to have control. We got to have something to compare it to. Okay, something to compare it to. Sometimes it is nothing, and sometimes it could be, like I said, what it was previously done. We got to have replication, right? We can't just do this one time. We need to do this several times. We need to have several trees. We need to have several people. They didn't do the whiff on just the one person. They did it on several people, okay? So we got to have that, okay? Got to have replication. How much replication? Again, the more information, the better, but at some point we need to make sure we have replication. I'm going a little too fast, I'm sorry. Control group, right? We got to have control. Got to have control. Got to have a baseline of somehow, some form, some fashion, and we got to have replication. Giving each treatment enough experimental units so we can tell the differences. Okay? If one tree is growing more, I don't think that's enough. I need to have more, right? How much? Well, we just need to replicate it. What was this one? Oh.
So, if I sign up for this drug trial, I take these pills not knowing if I'm getting the actual anxiety medication or a placebo?
The actual or the placebo, because he's getting some kind of medicine. Whoops, don't start over. Okay, good. Oh, you did.
So, if I sign up for this drug trial, I take these pills not knowing if I'm getting the actual anxiety medication or a placebo?
That's correct. The test group gets the actual medication and the control group is being given.
Test group, control group. So the control is the original or the baseline, what you're comparing it to.
Sugar pills.
So is there anything I should know about? Any side effects or anything?
Well, that's one of the purposes of the research. But in tests of this nature, common side effects include dry mouth, hair loss, blurred vision, inflamed gums,
Okay.
mild nausea, heart palpitations, liver damage, boils, shingles, sudden fainting, and temporary darkening of the stool.
Good Lord. How much do you pay people to do this?
$1,000 a week.
I'm in.
Hi, Alan.
Hi.
think I'm in the control group.
You're good. Control group. Normally you don't know until something happens. Yay. Single blind, single blind, single blind. Alan was single blinded. He did not know which one he was taking. He did not know which one he was taking. Either the subject or the people giving it did not know. Okay, so Alan was single blinded. He did not know until his hair started falling out which group he was in. And what I mean by the other one is, let's say that I'm testing a new food for dogs, and I claim that this food gives these dogs more energy, it makes them healthier, it makes them more active, it makes them more attentive, and they sleep less. That's the new food that I'm going to give them. So I give them the new food, and then I give them the old food. And then I go back the next week and I realize that these dogs are more active or more healthy and all that. Well, if I wanted it single blind, I would not know which dogs got what. Okay? So single blind, somebody, whoever's giving it or whoever's receiving it doesn't know. Whoever's giving it or whoever's receiving it doesn't know. That's a single blind test. Okay, single blind test. They also have double blind tests where that's who's receiving it doesn't know and who's giving it doesn't know. That's when both don't know. Now, somebody knows, right? Somebody has linked them somehow. But it's to help do what? Remove bias, right? It's my food. I think it's better, so I'm testing it. Well, if I want to help remove some of that bias or the placebo effect, if you will, right? Somebody has to know. But we have single blind and double blind. So single blind is either the people taking it or the people giving it don't know. One of those two doesn't know. Typically, if it's giving it, it's like to non-humans. Single blind is typically a human doesn't know by himself. If it's a non-human, then the person doing it doesn't know. Double blind is neither one of them knows. Most of this is dealing with humans. So single blind, double blind. One of the questions on one of the APs one year was, can this be blinded? Can this be can this experiment be blinded? It was yes or no. I mean, I think it was no, because the people know which floor they're living on. I think they were dividing it by floors of an apartment. Something like that. Okay, everybody good? All right. Almost. We're good. Okay. Completely randomized design. Now, I've done so much better with this than the first couple of years because I always called this SRS. I called this SRS. This is different than SRS, sort of. SRS is how we're selecting people to do things. Okay, that's how I'm gathering information. This is with an experiment. This is how I'm assigning the treatments. Okay, so a completely randomized design is similar to an SRS, but it's not an SRS because SRS is how I'm selecting them. Okay, this is more like the experimental units are randomly assigned into the treatment group. The experimental units, the brownie mixes, were randomly assigned into the gas oven and the electric oven and the different pans. Completely randomized. Completely randomized. I want to test, well, no, that's a bad example. I'd have to do it before y'all came in. I want to test where you sit in class or what effect you sitting in class has on your grade. So I throw all of your names into a hat and I pull one name out, and those people, as I'm pulling them out, they're going to sit here and they're going to sit here and they're going to sit here. And as I keep pulling them out, right, and that's completely randomized. Completely randomized. Completely randomized. Y'all kind of see how that kind of sounds like SRS. But I'm not selecting you to do something. I'm giving you guys a treatment. I'm telling you where to sit so that I can test what your grade is at the end of the semester. Completely randomized design. A total of 20 students have agreed to participate in an experiment. So what are these 20 people? What type, how did they get selected? It looks like voluntary, right? And I told y'all guys, you'll see voluntary a lot. You have to be careful about that, but you'll see it a lot. Okay? They've agreed to participate in an experiment in comparing the effects of caffeinated cola and caffeine-free cola on the pulse rates. So we have one factor, cola, 2 levels. Therefore, we have 2 treatments. Describe how you would randomly assign the 10 students into the 2 treatments using 20 identical slips of paper. Number the students, 1 through 20. Throw those 20 pieces of paper into a hat, mix them up thoroughly, pull out 10. The first 10 get the caffeine and the next 10 do not, or the remaining do not. How about that? You okay? If you want to say the first one gets the caffeine and the second one does not, you're okay that way. But then you have to do all of them, right? Whereas I'm going to get done faster because the first 10 and the remaining. When you're doing 1, 1, 1, 1, you got to do them all, except for the very last one. Y'all okay? Uh-oh, don't want that button. On 10 slips of paper, write down A or B. Here's another way to do it. 10 separate slips of paper, you write down A or B. You're throwing that into a hat, mixing them up, handing them out. A, B, A, B, B. But again, you got to do all of them, and you do it that way. If I want to use technology, number the students 1 through 20, use a calculator to randomly choose a number. The first 10 numbers get the caffeine and the remaining 10 do not. Making sure there's no repeats. Label each student with a different integer from 1 to 20. The randomly generated 10 different integers from 1 to 20. The students with these labels receive the cola with the caffeine. The remaining 10 students receive not. They didn't say anything about repeats. They probably get dinged. And then table D, number the students 0, 1 through 20. Number them from 0, 1 to 20. The first 10, yada, yada, yada. Label each students from 0, 1 to 20. Go to line of table D. Read 2-digit numbers moving from left to right. The first 10 different labels between 0, 1, and 20. Identify the 10 students who will receive it with caffeine. So here you have the experimental units, randomly assign them into the groups. Whether it be 1 group, 2 groups, 3 groups, or you're going to randomly assign them. Y'all okay with that in SRS? SRS is how you select them. I'm not selecting them, I'm assigning them. So this is a completely randomized experiment. Don't say SRS for this because you're not selecting them. Although they're similar. And then randomized block is similar to stratified. You're going to block them some way, some form, some fashion. Okay, you're going to block them. So let's go back to assigning you guys a spot in class. And I'm going to block you by grade. Okay, because I know I don't know if we have equal number, but we have some juniors and we have some seniors in this class. So I'm going to block you by grade. Right? And so I'm going to choose 2 out of this to be seniors and 1 to be a junior. Or somehow or another, depending on what the ratio is, right? They may all be seniors and this may all be juniors, and then this better be all seniors and this better be all juniors because I need 1 of each up here. But you're just trying to help control it. You're trying to help control it. And so a lot of people confuse this with stratify, right? Stratify by age, block by age. Block by age because I'm assigning it. I got these trees that are next to the water, and I got these trees that are not next to the water. If I do a completely randomized, all the ones next to the water could end up with a new fertilizer. I don't want that because then I got a confounding variable, which is the water. I don't know if the water's helping the trees grow or the fertilizer. Okay? So I might block, That way, half of these get the new and the old, and half of these get the new and the old. And that way I help remove that confounding variable, or I help even it out. Randomized block. Y'all okay with that? So we got 10 volunteers. 4 of these are smartphone users and 6 of them are not smartphone users. So we're going to randomly assign these smartphone users to keyboard A or keyboard B, and we're going to, the non-smartphone users, they're going to get keyboard A and keyboard B. And then we're going to compare this A and this B and this A and this B. And see if A is faster here and A is faster here, then A is probably better. If A is faster here and B is faster here, then A is faster for the smartphone users, but it's not for the, okay? So then we can combine adjusted whatever. So block, randomized block. Try not to say stratified when you're blocking, and don't say blocking when you're stratifying. That's when you're selecting. Stratification and SRS is how we're selecting them, assigning them. And these are only 2 assignments we have. Oh, I'm sorry, match pairs. That's a special block. Special block. So match pairs. You pair up some way, some form, some fashion. There's 2 trees right next to each other. I'm going to pair them up. Okay? The key is when you match pair, randomly assign 1 to 1. So match pairs in this class, I might have a junior female. I might pair them up. A junior female, pair them up. And a senior male, pair them up. I might have a senior male who's had 4 AP classes, or whatever I might do. I'm going to pair them up some way, some form, some fashion. That would make sense. One gets one and one gets the other. Sometimes one gets one and one gets the other, and then they wait a while and then they flip-flop. Sometimes. Sometimes they'll flip-flop. But pair them up some way, some form. It's kind of like blocking them. You're just blocking them in really, really small parts. It could be that they receive both. Just make sure you use the random. Make sure you use the word random. Randomly assign them. Randomly assign 1 to 1 and 1 to the other. Matched pairs. Matched pairs. This doesn't show up a whole lot. Like I said, it's kind of blocked. They kind of go together. Pencils, 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 pencils. If you're asked to design an experiment, you got to have those. You got to talk about those things. You got to have a comparison some way, whether it be a control group, whether it be, it doesn't have to be a control group, but you got to compare it some way. The fertilizer A, B, and C. Okay, I can compare all that. I can compare fertilizer A, fertilizer B. I can compare fertilizer A and fertilizer B, and I don't have to have a control per se. But somehow we have to compare them. Doesn't have to have a control, but we got to compare them. We got to have randomness in there some way, some form, some fashion. You got to have randomness in there. You can't just do it. You can't be biased. Randomness helps remove the bias. Control what you can control. If you think gender has something to do with it, then block by gender. If you think age has something to do with it, block by age. If you think that water has something to do with it, then block by the water and the non-water. Control what you can control. Keep other variables the same for the groups, especially variables that are likely to affect the response. If it's likely to affect it, then control it somehow. Somehow. Control helps to avoid confounding and reduces variability. And in replication, we got to do it more than one time. We got to have replication if you're asked to do it. make sure we talk about each one of those things. And it just typically will say design an experiment, which was last year's number 2. Design an experiment. I say that. That may have been selecting them. They don't ask this a whole lot because it's really hard to grade. It's really hard to grade. So make sure we compare, make sure we randomly, make sure we have control, make sure we replicate. Do I have those highlighted? Are those on your thing already written? I put this down in pretty low on the knowledge. Factors, levels, all that stuff's a lot higher. All right, guys, I hope you can explain the concept of confounding variables. Truthfully, to me, it's one of the hard. It's not that hard with multiple choice, but it's hard trying to explain it via words. And how it limits the ability to show cause and effect, distinguish between an observational study and an experiment. I told you AP doesn't try to trick you, but that's one of the things they'll try to trick you with. They'll give you an observational study and then they'll try to show cause and effect. And it's really easy to do. And I can prove that because my test results show it on one of my questions. You fall for it. Be careful. Identify the experimental units, treatments. Be able to describe the placebo effect and the purpose of blinding. The purpose of blinding is to try to, so that they don't know. They don't have that mental strength. Okay? The way you could fix that whiffed, right, was to actually give them water and give them whiffed and see if they did something different. Maybe let them know or maybe not let them know. I don't know. That's part of the mental part of it, I guess. But I hope you can describe how random assignment treatments, by using slips of paper, using technology, or using the table of digits, explain the purpose of comparison, random assignment, control, and replication, right? Comparison, well, that's pretty easy how we can explain it, right? We're trying to compare which one's better, which one's worse, or which one does good, which one doesn't. Random assignment helps try to remove all those confounding variables. Control, right? That also helps it. And then replication, we got to have it more than once. Describe a completely randomized design and describe a randomized block design, as well as matched pairs. Those kind of go together. And that's it. I think 4.2 is already assigned. I apologize, but there's quite a few questions. So you got 30 minutes. You probably can come close to knocking out a lot of it.